next presentation is by Dr. Alex Grant, CEO of Myriota. Dr. Grant, this is his second startup business, which he co-founded in 2015. It services a need for global satellite TV connectivity. The presentation today is entitled From Collaboration to Commercialisation. Please join me in welcoming Dr. Grant.
Right. Thank you very much, and thanks for coming out after lunch. Collaboration and commercialisation, and in fact, even some more collaboration. It's been a consistent theme, in my academic career and certainly in my startup career, and I think the power of collaboration is apparent when you can achieve things just far greater than you could ever do just by yourself. So I'm Alex Grant. I'm one of the founders, together with Dr. David Haley, of Myriota, and now Chief Executive Officer. And previously, as some of you may know, was a professor at the University of South Australia. So I want to talk about the Internet of Things. And it's something that you may have read about, you may know something about, or come into contact through media or internet articles. The Internet of Things at its heart is really about using digital connectivity and intelligence to make stuff better. So to improve operations, to make things less risky, to increase productivity, all those things that you want to achieve in any kind of endeavour. In the commercial world, and Myriota is very focused commercially, that has expressions in agriculture, in natural resource monitoring and resource management, in utilities, both from a metering perspective and a energy infrastructure monitoring perspective, through to things like marine aids to navigation, determining when the battery on a aid to navigation might be about to fail and having that replaced before it actually does fail, or doing things like providing tracking services for commercial fishing vessels so that they can meet their compliance requirements, through to all kinds of track and trace and monitoring in support of logistics. So not just where is the asset, but if it's some kind of machinery, how is it being used? Or if it's a stored equipment, how is it being stored? What's the environmental conditions? So all of these things I've sort of been mentioning have some common themes. They're about getting small amounts of data and doing some kind of intelligence with that to improve stuff. However, quite often there's a bottleneck, and that is getting the data. So if you want to get on your phone, here in Melbourne, we could all whip out our phones right now and send emails, do whatever. Connectivity is not a problem. You don't have to go too far out of cities and then that connectivity disappears. And you don't have to go even anywhere very exotic. You can do that here in Australia, in the 70% of our geography that has no cellular connectivity, or the 90% of the Earth's surface, including maritime areas, that again has no terrestrial-based, cellular type of connectivity. Yet there's a lot of activity in those areas of economic interest, and while Myriota is quite commercially focused in its early phases, everything I've just said around using data and intelligence to improve operations, I think resonates very strongly in a defence setting. And I'll talk a bit about some of the engagements we've had as a result with defence and some of the ongoing collaborations and projects that we're working on. For applications that need a low-cost device with a long battery life and low maintenance cost, it's been recognised that doing that with existing satellite systems kind of doesn't work out. Roughly speaking, the equipment's too big and bulky, the batteries don't last long enough for those deployments in remote areas, and just running the system is problematic. So that's kind of the roadblock that Myriota sort of first observed actually back in 2010. And we really set ourselves the goal of how do we solve a massive scale global access? How do we achieve a battery life that could be measured in years rather than hours or days? And how do we deliver all of that at a cost that's not a 5% decrease, but that is at least 10 times improvement on what's out in the market at the moment? So this was our Internet of Things connectivity challenge. And when we say global scale, massive scale global access, the Internet of Things is a $1 trillion opportunity for billions of devices. And you can sort of look at any analyst and take your pick. The particular choice of numbers will vary, but roughly that's the scale that people are talking about. So now coming to sort of how do we get from this roadblock, how do we overcome it, and then sort of do the commercialisation. So we've identified a market gap, and that gap is for small amounts of data, anywhere, low cost, long battery life. From that, you ask yourself, well, why does that gap exist? Why isn't it solved already? And in a research setting, so this was back at the University of South Australia, Institute for Telecommunications Research, we're looking for the deep problem that needs a scientific breakthrough in order to address this market gap. Overcoming that through a technology breakthrough, science breakthrough, then leads to some kind of what I would call a deep enabling technology. So, something that's, let's say, not superficial, something that really has a lot of technology behind it that is required to deliver a solution. And then ultimately come back full circle, delivering that back to market. So a new category of service, and importantly with global application and commercialising anything out of Australia. I'm from Adelaide, so I could choose to focus on the Adelaide market, the South Australian market, the Australian market. That's all important, but really lifting the eyes and saying, okay, we're going for a global application of the technology. And one of the things that I always like to stress is we did this as a very premeditated commercialisation. People ask me, how do you commercialise technology out of a university? And that has a very simple, if somewhat facile answer to it. You do it on purpose. A lot of R&D that occurs in universities and in publicly funded research organisations, the commercialisation can be kind of sometimes done a little bit after the fact. Science boffin's invented something. What do we do now? Can we license it? Can we make money out of it somehow? And one of the things that really differentiated our approach back in 2011 when we were first funded to look at this problem was even before we signed the funding deed with the Commonwealth, which was actually funded under the Australian Space Research Program, was to recognise that if we do the science right, the engineering right, there would be a commercialisation opportunity. So let's take a minute to figure out how that might look, how an agreement with, in this case, the University of South Australia would look, how does it affect the design of our research program, how does it affect the training of the research staff that is involved. So that was a 3-year program of research. It was a consortium project that had the University of South Australia, CSIRO, the Australian Institute of Marine Science, ComDev, a satellite equipment manufacturer from Canada, and Defence Science and Technology Organisation. So a very collaborative research project working on the spectrum from looking at what are the requirements, what's the need, what does the thing look like, what does it need to do, through to technology solutions. And then over the following 3 years, taking that technology from a blank piece of paper, doing the math, writing the code, getting proof of concept stuff up and running, and taking it as far as flying around a satellite payload inside the Defence Experimental Airborne Platform. A plane provided to us access to that via DST. which was a vital step to sort of increase the heritage on our system before going forward with satellite-based trials. A whole bunch of intellectual property resulted out of that, really pointing towards the eventual commercialisation and seed funding, which came in 2015. That seed funding came from a strategic partner, again, a kind of with a very collaborative approach, where not just the funding to get going, to hire people and start developing the product, but also providing access to a constellation of low Earth orbit satellites that are already on orbit so that we could start providing service immediately. Since then, we've had a bunch of funding going to the company. Products been demonstrated out in the field in a number of different projects, and I'll come back to what some of those are. And then this year, in March, we closed a fairly significant Series A investment that is now providing the capital to really take the product all the way to market and develop our global offering. And so just dwelling on that for a minute, that round was a $20 million round into a 2-year-old company, which is significant in the Australian context. It was led by Main Sequence Ventures and the South Australian Venture Capital Fund, which was important. That anchored the investment in local VC that was supporting the company, and then that provided the framework or the confidence into which companies like Boeing and Singtel Innovate could invest out of the United States. And we're very proud of the fact that Myriota was the first investment made by Boeing in a startup that's not in the United States. So not the first one in Australia, the first one not in the United States. People ask me, so what's the secret to that? How did that happen? Having the rest of the funding ecosystem in place for that, but ultimately deep technology and a global opportunity. So world-leading technology, global opportunity. That's the kind of thing that investors like that are looking for. Alongside that, our engagement with defence to date was definitely a determining factor. So the collaborations, the projects that we had done with defence to that point were definitely feeding into those decisions, which I think speaks to even smaller scale interactions like that this is really an area where defence can help out and startups, not necessarily by funding them directly, but by just having that interaction and perhaps some funding as well to get going. But that relationship certainly was important for us. So, all right, so what is it that we do? So Myriota Direct to Orbit. It's a device like that one. It's kind of a big picture. That's the current generation product. It's a tiny little piece of electronics. We call it a sensor to cloud interface. So you can integrate this with whatever sensor you like. That then provides a direct to orbit connectivity capability. And in fact, it provides a bit more than that. Connectivity, computing, memory on board, so data logging, pre-processing, all kinds of standard sensor interfaces to make that integration into systems very easy. You can trigger it, you can wake it up, you can respond, you can do all kinds of interesting things. Has onboard smart power management so that we get very, very long battery lives. And like all good electronics, actually under the hood, it's actually acronym powered. Sorry for that. Little device communicating directly to a constellation of satellites in low Earth orbit. And that's a really important architectural distinction. So, if I want to have a connected cow, I put this on the cow, that's it, that's all I need to do. No other infrastructure required. If I want to be tracking the location of a storage container talks directly to the satellite. These are the satellites we have, the orbits that we have right now today, 3 polar Earth orbiting satellites and 1 equatorial satellite. They're at altitudes of between 500 and 800 kilometres, and they are owned by one of our investors, Exact Earth, which is a Canadian-based company whose primary business is maritime vessel tracking. The picture you can see is a 3U CubeSat, which will be launched later this year, and we have a collaboration program associated with that satellite, again with DST Group, to do some experiments with that satellite. What you're looking at there is larger than real size. Right? That's a 30 centimetre tall satellite, which is where some of the economics comes in of why these, people talk about responsive space, small space, space 2.0. The cost of those assets really plays into the infrastructure cost. Just to emphasise that a little bit further, on the left you see a silhouette of SkyMuster, one of the NBN satellites. They have two of these satellites, and those lines, the scale there is 1 metre. Right, so it's a 9 metre tall, 6.5 tonne satellite that's inserted into geosynchronous orbit. And on the right, we have a $1 million 5 kilogram shoebox that can provide data connectivity to billions of devices globally, which is kind of exciting. Let's put the orbits into perspective. So, here you are on this blue dot on the left. Just to get some bearings, there's the moon at 384,000 kilometres away. And then that white circle is geosynchronous orbit. So that's where we park the $300 million satellite, and in fact, any number of large, expensive, monolithic satellites. The next white circle you see there, that's low Earth orbit at 500 kilometres altitude. Like when you see it to the scale like that, and this is to scale, you see how low we mean by low Earth orbit. That has great advantages for us as a communications company in terms of the radio frequency power required to close a link with a satellite like that. The other thing it gives us is it gives us global revisit even with a single asset. So a polar Earth orbiting satellite eventually sees every point on the Earth's surface between 4 and 6 times a day, whereas a geosynchronous asset gives you persistence over a particular portion of the Earth's surface. Something's gone wrong there, but I'll tell you about what this is. So we have a patent portfolio of getting onwards to 20 patents, 10 of which came from the university, were tipped into the company, and another 10 patents filed in the intervening time since the company's been incorporated. And I just mention that because there's an ongoing program of innovation within the company to deliver massive scalability, to deliver end-to-end security, which is actually quite difficult. Narrowband, short messages, robust security on those things. Internet of Things generally, terrible reputation. So doing security properly, quite difficult, intellectual property in that area. And then also the ability to geolocate devices on the ground without the need to be running a GPS or GNSS receiver on the device. Now, in the commercial world, that's great because it saves battery. In a defence setting, it's interesting in that we can position our devices without needing to have access to the GPS network. Interesting. These are some of the signals received from space, and it's some of the characteristics. So these are signals that are essentially invisible once received at the satellite. And not only that, these massive red things you see are actually interference. So they are other signals, in the band. From space, we're seeing a lot of the Earth at once, so we see all kinds of interference. And even if we land in the middle of stuff like that, we're still receiving things. So very robust and simultaneously low power signal for a system that's designed to be very, very power efficient, asleep all the time. Satellite comes over, blip, go immediately back to sleep. No complex handshaking, no session build up. So billions of devices, a multi-year battery life, 10 times cost reduction. And multi-year battery life, what we mean by that is something like 4 years on 2 AA batteries. So some of the projects, deployments we've done: livestock water monitoring in partnership with the Australian Livestock Innovation Program and the CRC for spatial information. So these are some sites around Australia. This is the app that the farmer sees. Something as simple as how much water is in my water tank, are my cows going thirsty, replacing manual site visit for those remote tanks, even 300 kilometres east of Broome up in Liveringga. Oceanographic drifters for marine science with the Australian Institute of Marine Science for things like currents, temperature, humidity and pressure. And more recently, working with another South Australian company, Ping, who do acoustic analysis of equipment for preventative maintenance purposes and then backhauling that data so that there doesn't need to be as frequent site visits for the maintenance of those wind turbines. So moving on to collaborations with DST Group, the Fight Recorder program is really interesting. It's a wearable device that we're developing together with DST Group and New Zealand company iMeasureU to provide a personal beacon in the case of something going wrong, and kind of a flight recorder type of functionality to be able to look at data after the fact to see what's going on. So that program's in full swing. I think this is one of the first projects, first cabs off the rank for the Next Generation Technologies Fund, and this has been a really successful and smooth collaboration for us. I've been, and I shouldn't be surprised, but I've been very surprised and really happy with the speed and engagement of defence in these kinds of projects. And then moving on to Internet of Military Things, so small, light, multi-year battery, supporting a wide range of sensors. We're supporting DST for the contested urban environment exercise next week in Canada. Very exciting project. And a similar sort of a related project with a smart storage box, so looking at remotely stored assets and the environmental condition of those assets for health monitoring of the things in those boxes. And then finally, so sort of coming full circle back to collaboration, Myriota has been funded by the South Australian State Government to set up an innovation laboratory, so really to make our facilities, capability and core technology available to all kinds of partners, academia, defence, industry, to develop solutions across a wide set of industry verticals. So we're very much open for business. Ultimately, we're a technology provider, a solutions provider, but I think I just want to emphasise, our approach is to work with other companies who can then deliver solutions to their customers. I'll leave it there. Thank you. I think we have a few minutes for anyone who has a question. There's a few up here.
Please wait. This session's being live streamed and the microphones are covered.
Greg Reid from Clearbox Systems. Thank you very much. That was a great talk, and it's great to see an Australian company startup doing so well. At the panel we had earlier on innovation, a question was asked about patents. And I noticed you said you had 20 patents. I'm curious as to the resources, the overhead, how you manage that as a small company, if you're able to share some of that.
Yeah, so patents are an expensive proposition. On our budget, it's our second most expensive thing after people and satellites. The way that we manage that is, that's the investment proposition. So the reason that companies like Boeing have invested in us is because of our technology, and our IP portfolio really makes that defensible and articulates our IP. That's definitely one of our differentiators as Myriota compared to a number of competitors around the world, in that we've got a technological solution and we have protection of that. So that was very much. We had investors who literally said that's the most important slide in your deck. But yes, it's expensive and also time-consuming to manage. One more question before we have to wrap up. I think there was someone else on this side. No? Oh.
So I think at the top of your talk you mentioned that, Ian Gibson from University of New South Wales. At the top of the talk you mentioned that you had a global market strategy from day one. What's your, as a startup, how do you resource a global marketing and sales activity? That's
a brilliant question. And the way that we do that is to partner with people who have those distribution channels. So we're right now, with our early access program, working with a number of global companies to work with them to integrate our technology into their products, for which they already have existing distribution channels, marketing, support, and so forth. So if we tried to scale our product over a wide range of industry verticals and geographies, we would just die, right? That doesn't work. So we've really given a lot of thought to where we fit in the value chain and who we partner with, who can basically deliver that scalability through collaboration and partnership. All right.
I'm sorry, we're going to have to shut it off there. Thank you very much, Dr. Grant. Please join me in thanking Dr. Grant.